So for our term project 1, we're doing chapter 6 foundations in our group. It's group 2. Our group is Carlos, Omar, Ashlyn, Chad, Isaiah, Bryce, and Eduardo, me. For the types of foundation we have slab and raft foundation. Examples of this is slab on grade, post-tension slab on grade, mat foundations. We also have shallow foundations, spread footings, or examples of this is spread footings, independent footings, and grade beams. We also have deep foundations. Examples of this is non-displacement piles, displacement piles, and helical piles. More about slab and raft foundations. Slab on grade, reinforced concrete foundations that is placed directly on the ground and to provide structural support for a structure. In Southeast Texas, perimeter thickened edge is needed to support interior load-bearing components, and formwork built at the edge as well as a moisture barrier is usually used to protect the slab from excessive ground and moisture.
Now we're going to be talking about slab and raft foundations. This is the post-tension slab on grade. This type of foundation is used when there is unstable soil or not enough ground support. It uses high-strength reinforcing steel inside plastic ducts with tension anchors. After concrete reaches a certain strength designated by the liner, tendons are stressed and the ends are cut off. It reduces cracking and eliminates control joints. Mat foundations. This is a reinforced concrete slab that covers the total footprint of the building. It spreads weight evenly, includes beams and support all at once. Now we're talking about shallow foundations. These are used for spread footings, or also known as strip footings. This provides a stable foundation around the perimeter of the structure, subgraded to be compacted. Independent footings, enlargement at the bottom of the column or interior bearing wall that spreads the applied loads over a larger area. Grade beams, reinforced concrete beams that are supported by a series of concrete piers. These are used where expansive soils may cause foundation heaving. Deep foundations, non-displacement piles, drilled or bored piles. These are used for in-bearing units that are drilled using large diameter drilling rigs, typically used with stiff clays and soils. They're also continuous flight auger, basically a large drill bit that can form a bored pile in one continuous process. Now we're talking about deep foundations.
Alright, so some examples for deep foundations. They use displacement piles, also known as driven piles. They use to move solids vertically as timber. They use steel or precast concrete pile shafting that's driven and or mechanically vibrated into the ground. The helical piles, also known as screw piles, they use helical steel piers installed at intervals between the footing forms. They're installed by screwing steel into the soil, and the torque of a motor drill is required to bear the capacity of soil and to find out the anchor depth needed to support the required structural load. And now some methods of pile driving would be a drop hammer, and a drop hammer uses a heavy weight lifted by vertical rails by leads. And the weight reaches the top of the rail and then is released and falls into the pile until the pile reaches the required depth. There's also a single acting steam hammer, which is mounted on the top of a pile, and the hammer or ram is lifted by either steam or compressed air. And there's also a double acting steam hammer, which is virtually the same as a single acting steam hammer, except on the downstroke, the steam pressure is applied to the backside of the piston. Some further ones are diesel power hammers, which includes a vertical cylinder, a ram, an anvil, and a diesel power unit. They use compressed fuel and heat that cause an explosion to continue the hammer cycle. There's also a vibratory pile hammer that's held by a crane and mounted on the end of a pile. The motor drives the weight in opposing directions, creating vibrations that are transmitted to the pile. This also agitates soils, reduces friction between the pile and soil, and it's also difficult to use in dry sand and cohesive soils like clay.
Now we're going to talk about inspections. So earthwork is essential before the ground is broken, just to know what soils you're working with. Job materials and tool inspection. Faulty tools can lead to dangerous work environments and serious accidents. Steel pre-pour inspection, when the foundation makeup has been completed and the builder is ready to pour concrete. And final foundation inspection is performed when all foundations are set and complete, which is before the job progresses any further and any structure is built. Installing concrete, some steps for that is surveying and building permits, prepare the site and evacuation, so you're going to level the ground that you're going to build on. Formwork, which is the fixed molds to hold the concrete into place as it's poured. Then you're going to fill and level and pack inside the formwork. Then you install your grids of rebar and triple check everything before you pour and level. Round off the slab edges, set bolts and control joints, and then you let it cure.
So now we talk about the concrete levelers. So first we have the tampers, which pushes aggregate and sand / gravel down and cement to top. We got bone floats, smooth cement paste. After tamping allows contractor to reach further onto the slab without walking on wet cement. These are some examples of what those look like. Some more we have are derbies. Float concrete in small areas where bull float would be practical, used on stairs and sidewalks. Next we have trowel, many sizes and edges usually used to go around pipes. So now, next after that we'll be curing the concrete. We'll be using ACI, American Concrete Institute standards written in a mandatory language, concrete specs and guidelines. Length of curing affects the final strength of concrete slab. We'll be keeping moisture and control the temperature. Exposed concrete should be covered with a sheet to prevent debris from landing on wet cement. Continuously sprinkle the surface with water. Curing compounds can be added to reduce water loss. If water evaporates too quickly, the strength of the slab will be compromised and could crack.
Types of support systems used in foundation are beams, 24-inch stirrups tied with number 3 ties, and 6 number 5 rebars. Typically, that's just an example we got off of the internet. Some pile types are 18-inch steel cages with 5 and 5 rebars, 8 foot deep, with a 36-inch bell at the bottom of the pile, and a 3/8-inch tie at 18 inches with a pinch of 16 by 36 inches. Corner bars are number 6 rebar tied top to bottom with 4 foot overlap on both sides. As you can see over here, these are like the corner ones that they use. They're like L brackets basically. And the concrete slab is like a 5-inch concrete slab with number 4 PSI. 28-inch at 28 days, number 3 rebar at 16-inch center to center over 6 mil polyurethane vapor barrier over 4 inches of sand fill. Some materials used in general foundation is porcelain cement, concrete, steel bars, mesh wires. You can see right here. And then there's chairs. There's chairs usually underneath the beams, and sometimes they use plastic chairs for the wire mesh. And then there's usually rebar, which is number 3 or number 4 or even number 5, and then flinch and the 3/8-inch stirrups, circular stirrups that they use for piles. They're usually this wide. Depends on how big. Sometimes there's like 14 or sometimes there's 16 depending on how big the pile is. And then there's 24-inch rectangle stirrups, which are these right here, and they're installed in the beam, the rectangular ones, and they're tied with number 3 ties.
To summarize the presentation, there are 3 main types of foundation: slab and raft foundations, deep foundations, and shallow foundations. And you can see we have a deep foundations, an example picture, and shallow foundations. Next, numerous methods of pile driving: drop hammer, single acting steam hammer, double acting steam hammer, diesel pile hammer, vibratory pile hammer, and important tasks and components of construction: inspections, surveys, concrete curing, support systems. And we have an example picture of foundation. And here's our works cited where you can find all the information that we used.